Welcome to Ask and Learn.
All right. So for this problem, we have three processes: A, B, and C. So they're one of them isochoric, adiabatic, or the isobaric. But we don't know which one's which. So to figure this out, we uh, but we also know that the initial temperature and the final temperature are the same. T1 is the initial one, and T2 is the final one. So if we draw the PV diagram, this is P, this is V. So this curve represents that the temperature is T2. This curve represents that the temperature is T1. This is T1, sorry, T1. And the three processes, so isobaric means the P is constant, so it's a horizontal line. Isochoric is V is constant, so it's this line. And adiabatic is just a curve. Suppose it's like this. But we do not know the direction yet. Let me see. So suppose the three processes we label this one is 1, and the isochoric is 2, adiabatic is 3. Okay. So we know that for the adiabatic process, which is 3, for adiabatic process, it's always 0. And if we look at this this bar chart, we see that on A has 0 Q. So this is a QA. So it means that A is adiabatic. And for the process B, we know QB is 30 joules. And no, that's not what I want to say. Just erase it. Right, we should still looking at the top top right figure. All right. And Q1, okay. Q1 is basically the isobaric process. So the Q1 will be equal to the work done by the gas plus delta U. Okay. And for Q2, as we can see, this is isochoric process. So the work is 0. It only equal to delta U. Okay. As we can read from the problem, it says that we have some heat flowing into the gas. So that means energy, the internal energy should be positive. In that case, the volume of the gas also should increase. So Q1 should be the largest, Q2 should be the smallest, Q2 should be smaller than Q1. And in that case, we can see from this diagram, Q2 should be QB, and Q1 is the largest, it should be QC. So you can see that A is the adiabatic process, B is the isochoric process, and the C is the isobaric process. So this is part A. Okay. Part B, we want to figure out the T2. To do that, we can start from the process B, because process B we only have the delta U. Delta U equal to 30 joules, as we can read from here, 30 joules. And it equal to N times CV times delta T. All right. N is given here 0.3, and CV is simply 3/2 times R, because this is ideal gas, and times delta T. Okay. So we can plug in the value of R and to find out delta T. The one I found, delta T is simply equal to 8 Kelvin. So T2 should equal to T1 plus delta T equal to 28 Celsius degrees. Okay, so this is T2. For part C, uh, we want to find out the work. So uh, the work in the work for the work for Q1, not Q1, the work for QA, which is adiabatic process, because Q is 0, so work is simply equal to negative delta U. Because for this problem, the T1, T2 are the same for all the three processes. So delta U is the same for all the three processes. Okay, so delta U we found here uh, is just the 30 joules. So for the A process, that it's just a negative delta U, which is negative 30 joules. And for WB, which is this one, this isochoric process, it's isochoric process. In this case, the work is 0 because the volume does not change. And for the for the process C, it's equal to the QC minus delta U. And delta U, as we said, it's 30 joules, and QC is 50, so it's 20 joules. So these are the work for the three processes. And for part D, so simplest one would be this one, this process B, because the volume does not change. So delta VB equal to 0. So this has to be the smallest one. So the problem is, what is the volume change for A and C? Remember, for A, it is adiabatic process. So we have for A process. So process A, T initial times V initial gamma minus 1 equal to T final V final gamma minus 1, right? And gamma, I just write here, gamma for this problem, because this is ideal gas, so it's just equal to 5/3 by default, okay? So we already know the Ti and Tf. So Ti equal to 20 plus 273, which is 293 Kelvin, and Tf equal to 301 Kelvin. Okay, so we can obtain the relation between Vi and the Vf. So Vf, Vi, sorry, there's no room here. I need to find somewhere else. Let me see. Okay, I'll just put it here. Okay, maybe I need to write it smaller. So we can obtain Vf over Vi equal to 293. That is the initial temperature over 301. The power is 3/2. Okay. And for process B, no, for process C, we have because the pressure is constant, so we have Ti over Vi equal to Tf over Vf. All right. So this is A, And for C that we obtain VF over VI. Now it's there. I can right here. There is no loom. Oh, come on. VF over VI equal to 301 over 293. Okay. If you compare these two results, you'll see that this one, okay, this is for process C. This line is for process A. You'll see that the magnitude of change in volume for process A is larger. You just need to compare these numbers. Okay, there is no room for me to write. So I just tell the result. So for process A, this is larger. Okay, so for part E, we want to know if the volume decrease or increase for the three processes. So you can also find out this result from the previous calculation, because for process A, uh, this is the final, this is the initial. So for process A, it's decrease. This is A, and for process C, it's the V final is larger, so it increase. And for process B, it actually the V is constant, so this is B. Okay, yeah, that's it.